All right, so this, obviously, this section, we put those last two together, which was your horizontal asymptotes, vertical asymptotes, and then we included slants and holes, all that stuff put together. So this kind of separated out a little bit, but on your test, there's two big questions that basically have all those parts. We're going to go through that process in a little bit, but number one here just says find the vertical and horizontal asymptote for the graph of the rational function and then graph the function. So for vertical asymptote, we would look at the bottom. I would factor this out. I get x plus 4 and x minus 4. Set them each equal to 0, and I get x equals negative 4 and x equals positive 4. So remember, it has to be x equals. You could do x equals plus and minus 4, but the x equals has to be there because these are equations. So if I were to just put those alone on my graph at negative 4 and positive 4, I'd have a dashed line for the asymptotes. Then for your horizontal asymptote, you're looking at the exponents in the top and the bottom. This time they're the same, so this is that leading coefficient one. So it would be y equals the leading coefficient of the numerator, which is 4, over the leading coefficient of the denominator, which is 1. So my horizontal asymptote, and again, it has to be an equation, is also at 4, but it's at y equals 4. With me so far? Okay, then it said graph, but obviously it didn't give you all the parts. Like on the test, you will get points for all the parts. So you're going to continue to do all the rest of it, okay? And it will say slant asymptote, and if there's none, you put none. And if it says holes and there's none, you put none, okay? But you're going to check for them each time. So I know I need more than this. The next thing we would normally do is your zeros. For the zeros, I set my numerator equal to 0. So if 4x squared equals 0, x squared would equal 0. And x would equal plus and minus the square root of 0, which is 0, but why is it important that there's two of them? Because it bounces. So I know that that helps me with my shape in the middle. It's a parabola of some sort, okay? It either is going to go up or it's going to go down. The fact that there's no other 0 means that my graph cannot cross on either side here, and that tells me it's going to happen up here and up here. But if I had extra time or I was uncertain about either of those things, then I would certainly plug in a point. So I would take a point to the right of positive 4 or left of negative 4 and plug it in. So let's just say I was plugging in 5. I'd get 4 times 5 squared over 5 squared minus 16, which is 4 times 25 or 100 over 25 minus 16 or 9. So that's like, you know, like obviously not a whole number, but if I were to reduce that, I'd get what? How many times is 9 going 100? 11 times, yes, because it'd be 99. 11 and 1/9, right? You don't even need that to be exact, but to know that it would be more than 4, right? So that confirms that this graph is up here. Then symmetry helps you because this has y-axis symmetry, which tells me the same exact thing would happen on the other side. If I plugged in negative 5, I would get the same answer, which would also confirm this is happening up here. So if you understand symmetry, if you understand that the zeros mean it can't pass through, then it helps you eliminate that step. You do not need to plug in those points. But if you don't know, then obviously I would say I would definitely plug in those points. You do not have to if you understand that the graph does not cross there.
Okay, so if it doesn't have x-intercepts, then it wouldn't, yeah, it would only go
Yep. I would just say if you had extra time, and you might this time because it's not a ton of content on this test, I would just say if I had extra time, that would be the one I would go back and check. Because if you, for some reason, missed a 0, now you're basing everything off of that. Does that make sense? And maybe plug in a point and just check. So then if I want to know what's happening on the inside, it's a parabola shape. I assume it goes the opposite direction because the parabola is typically the opposite directions of if they're both going up and both going down. But again, you can plug in a point. So if I plugged in 1, which is the easiest, I'd get 4 over 1 minus 16, and I get 4 over negative 15. That's negative. That's under my axis. If I plug in negative 1, I get the same answer. It would be negative, and it would be under my axis, and it confirms the parabola shape. Questions? So 2 big questions like that broken down into parts in which they will all be worth points, okay? All right, then 2 said find the slant asymptote. So it's straight up telling you it's slant. How do I know it's slant if it doesn't tell you? So it has to be one more, right? So the exponent in the top is 2, exponent in the bottom is 1. It has to be one more. That's what tells you it's slant because it's not going to flat out tell you find the slant. So I know there's slant because the exponent in the top is one more than the bottom. And then to find it, we divide. This time you can actually use synthetic division. If it was x squared in the bottom, you'd have to use long division, but I can use synthetic. I am missing my x term, so I have to make sure I do 3, then 0, then 1. And then the opposite of what follows the x goes on the outside. Bring down the 3, multiply it, put it in the next column, add it, multiply, put it in the next column, but it doesn't matter for that end because we ignore the remainder. The 3 gets the x, and the 9 would be positive. So it would be y equals 3x plus 9. Also must be in equation form. So every asymptote you give has to be in equation form. That's a silly way to lose points. Okay, you don't want to do that. Questions? So let's say I went further with that, and let's say you wanted to actually graph it. If I wanted to graph 3x plus 9, I'd go up to 9. I'd plot my y-intercept. I'd go up 3 and to the right one, or down 3 and to the left one. And I'd draw my slant asymptote. I have a vertical asymptote this time because there's a term still on the bottom. So I would have a vertical asymptote at x equals 3. I'd plot my vertical asymptote. Now, even though it's really high up there, I still have to figure out, does my graph occur in this quadrant and this quadrant, or corner and corner, or does it happen in this corner or in this corner? So I can plug in points, okay? I could use my zeros. There's actually no zeros this time because this would result in imaginary numbers. So that it helps a little bit. If there was a 0 over here, it would have to cross through in here. But it could also be below this in the middle. So I would say this is one of those scenarios in which you'd want to find your y-intercept. It's going to be part of your question anyways. So I'd plug in 0 for x, and I'd get 1 over negative 1/3. Now I know I'm down here. So my graph is going to come here. It's not going to cross through the x-axis because there's no 0. And then that means it's going to be opposite corner from there all the way up there in the top. So even if it's up high in the top there, you have to figure out what spot it's in. There has to be 2 arcs if there's a slant asymptote. Noah? There were no x values, so it didn't help us. So, I mean, it kind of helps you because it knows that you can't cross through here and here. But, like, you might be able to cross through there if I went high enough in there. So I would have to know that this also happened below the x-axis. And, honestly, it's going to ask for it anyways. It's going to ask for all those parts. Yeah. Sure. Do you know what it is? 12 minus 2x?
Minus x squared.
Yeah.
And then under it was 2 parentheses 4 plus x parentheses.
Okay. So all the parts or something specific?
I have to know how to get the slant.
Okay. So first of all, the top's not in the order that it needs to be.
Yeah.
So I would rearrange it. And then the bottom, I would actually distribute that and rearrange it. So my bottom is this. So if you're finding slant, this one gets messy because of the coefficient. But I would divide top by bottom. And it hasn't, I don't know if it's happened to us yet, but in order to get 2x to become x squared, okay, you actually have to multiply by a fraction. So what we do is we say, what do I multiply what's on the outside to get the inside? But what's really happening is you're taking this term and dividing it by this term. So if I did negative x squared divided by 2x, that tells you what you have to multiply on the top. So the x squareds would cancel, right? And it would be negative 1/2 x if you wrote it in like with the coefficient on the front. That's what you would have to multiply both these terms by. So it can happen, it doesn't happen a lot, but it can happen that you have to multiply by a fraction so that that whole number on the outside goes away. So you're just taking this first term and dividing it by the first term if that happens. Okay? Yeah.
Is that gonna happen on the test?
Probably not.
And how many blanks are on the test?
Like 20, I think. Yeah, if you count them all. Questions? Okay, so let's go through concepts. So although this test is technically 2.5 to 2.7, a lot gets pulled in from 2.3. So we'll go section by section. If I would recommend you write the stuff down if you want to, okay? But we'll go over. So although, again, like I said, it's 2.5 to 2.7, it does pull back the stuff from 2.3. The only difference between 2.3 and 2.5 was that 2.5 now included imaginary roots. 2.5 is what was on your quiz, hopefully getting those back to you tomorrow so that you can check over all that stuff. Yeah. Yeah, no, I didn't post it. I mean, I can. All right, so the first thing that came from the beginning of the chapter, but again came back when we started doing imaginary numbers, and that was on your quiz, was the quadratic formula. So you're going to like straight up get a question that just is solved using quadratic formula. So negative b plus and minus the square root of b squared minus 4ac over 2a. I would say most of you did it right on your quiz, so hopefully you just repeat it again. The biggest thing is careful when you're simplifying. The square roots have to be simplified. If there's a negative underneath, the I has to come out. That's the only difference, okay? And then again, technically it's 2.3, but it came back in 2.5. That's why it's on here again. You are going to get a question that gives you a function, and we haven't had to test possibles yet on a test or a quiz. This is when it's happening, okay? So you are going to get a function. It is not awful, but there are going to be multiple roots. You're going to test your roots, okay? You're not getting a calculator to find one this time. You have to find it using your possibles. So you're going to build your bank of possibles doing plus and minus last over first. You're going to give me all of those. That's 5 points, okay? Then you're going to actually use Descartes' rule to figure out the number of positive and negative. Remember, positive we count, the sign changes. Negative, we change the sign on the x and then count again. And we subtract by 2. So if there are 2 sign changes, it's 2 or 0. If there were 3 sign changes, it's 3 or 1. That is also worth points. Then you're going to find the actuals, and this is where you're going to have to test your roots. Again, I'm not killing you on it, okay, but it won't be factorable by grouping. You're going to have to find the one that works. Use Descartes' rule to help you out, okay? If it says there's 1 positive, then use the positives first. If it says there's 1 negative, use the negatives first. And then you'll find the actual roots, and then you'll write them as a product of linear factors. So all this is what, again, came up in 2.5. The difference between 2.3 and 2.5 is that some of these came in complex pairs. So once you find the one that works, you're going to reduce your, which is cubic, so you're going to reduce it to x squared. And then from there, you'd either be able to factor it or use the quadratic to find the remaining roots. And there is a line that literally says, give the linear factors. You want to make sure you would write it as x minus x plus, whatever it is. And then there's one that says, find all the actual roots, and those you'll list, like x equals the number, comma, the number, comma, the number. You don't even need x equals, as long as you just have the answers there. Questions on any of that stuff? Okay, then in 2.5, we had it before too. We had it in 2.2, but we also had it in 2.5. If I give you a 0, find the rest of them. But in 2.5 came the imaginary ones. So this was on your quiz as well. It was a single term on your quiz, okay? It's going to be a binomial. So it said, given one complex 0, find all the zeros. So if I give you that one of the zeros is 2 minus I, what's the other 0? 2 plus I. And then we have to expand these. So I have to do x minus 2 minus I and x minus 2 plus I. That minus gets distributed to both, so it's x minus 2 plus I and x minus 2 minus I. And then that gets FOILed out. So I do the first, which is x squared, the middle, negative 2x, negative ix or xi, order doesn't matter, negative 2x, positive 4, positive 2i, and then positive ix, negative 2i, negative I squared. So I get x squared minus 4x. The ix and the positive ix cancel out. The 2i and the negative 2i cancel out. And that minus I squared becomes minus a negative 1 or plus 1. So 4 plus 1 is 5. Now that's 2 of the roots. So in order to find the remaining one, because there would be 3. Okay, this is corrected. This should be 32x minus 15. So now you have to divide. 4x to the third minus 19x squared plus 32x minus 15 by x squared minus 4x plus 5. So I'd have to multiply by 4x. Change your signs. Cancels. Negative 3x squared plus 12x minus 15. I'd have to multiply by negative 3. Can't read that. And then change your signs. And it cancels, okay, which it should. So then my remaining 0 comes from my quotient, which would be 3/4. And if it says find all the zeros, I need 2 plus I, 2 minus I, and 3/4. Questions on that one? Then came everything relating to your graph. So that was like your 2, 3 to 2, 5-ish, okay? Then came 2, 6, and 2, 7, which is everything relating to your rational functions. So the order of steps is important because you want to make sure that you don't miss any holes, that you don't miss a factor on your domain, that kind of stuff. So the very first thing we're going to do is factor. We're going to factor the top and the bottom. Then we find domain. Before we cancel anything out, we find domain by setting the denominator not equal to 0, and that answer has to be given in interval notation. Then we look for the holes, okay? If you can simplify by canceling something out in the top and the bottom, then there is a hole. And whatever you're canceling out is the x coordinate of your hole, okay? We're going to go back to holes in a second, though. If there is no hole, or even if there is a hole but there's still something left in the denominator, then there's a vertical asymptote, and you would set the denominator equal to 0. This is an x equals a number. It has to be an equation. The horizontal asymptotes, you're looking for the highest exponent in the top, highest exponent in the bottom. If the top is less than the bottom, then my horizontal asymptote is y equals 0. If they're equal, it's the leading coefficient of the numerator over leading coefficient of the denominator. And if it's greater than, then there's no horizontal asymptote. Then I go to slant. Slant is if the exponent in the top is 1 more than the bottom. We divide the top by the bottom and ignore the remainder, and this answer is in your y equals mx plus b format. So all of the asymptotes have to be equations. Then I would find the zeros. I set the numerator equal to 0. Pay attention to multiplicity, right? Because like the one in the warm-up, it bounced. And you just list those, like 2, negative 3, okay? Something like that. Then we find the y-intercepts. We plug 0 in for x. This is an intercept, so it's given in coordinate point form, 0, comma, the answer. And then you're going to graph by hand. If you need to plug in points, you will. If not, if you can go off of the information that's given and you're confident, then that's fine too. But you have to make sure that if you're unsure or you have extra time, you want to plug in points. All right, I'm going to go back up to the hole, okay? If I do have a hole, so let's say I have x plus 3 over x plus 3, x minus 3. When I cancel these, it does not cancel out my domain, which is why I do the domain from before this, but it does give me a hole at x equals negative 3, okay? I solve the one I canceled out. How do I find the y coordinate of the hole? Where? No, so I'm so glad you said that. You plug in negative 3 into the updated one. So the only thing that comes from the original equation when there's a hole is the domain and the x coordinate of your hole. This I would now take and plug in my updated, which would be 1 over x minus 3. I'd get 1 over negative 3 minus 3, which is negative 1/6, and that's the y coordinate of my hole. I would look for a vertical asymptote, which there is one, from my updated equation. I would look for a horizontal asymptote from my updated equation. There is one. It's y equals 0. I'd look for my zeros from my updated one. There are no zeros. I'd look for my y-intercept on my updated one, and there is. It's negative 1/3. So all the things with the exception of the x coordinate of your hole and the domain come after you simplify that equation. So only domain, and x coordinate of the whole come from the original. All others come from the updated equation or simplified. Yeah.
If you like miss the whole or you put it into the original one, you just get everything wrong.
I mean, technically, yes, but I would do like a carry through mistake. So you would miss the whole question probably, but then the rest, as long as you show your work and you're basing it off of a wrong function, then you won't lose all of it. Yeah. That would be disastrous.
Maybe we can see.
Yeah.